Day 4, question 1. Cole, can you please read?
The graphs of the polar curves R1 equals 6 sine 3 theta and R2 equals 3 are shown to the right. Find the coordinates of the points of intersection of both curves. 0 is less than or greater than theta is less than or greater than pi over 2. Write your answers using polar coordinates.
All right, fantastic, fantastic. So what we need to do is we need to find these intersections. So how do we find the intersections? We need to set them equal. So let's do it. So we're going to set 6 sine 3 theta equal to 3. All right, and so now what do we need to do to solve for sine? We divide by 6. So sine of 3 theta is equal to 1/2. And remember from pre-calc, we kind of cover up the 3 theta. So when does sine equal 1/2? At pi over 6. And when else? 5 pi over 6. All right. And so have I solved for theta yet, though? No. So it's 3 theta equals pi over 6, and 3 theta equals 5 pi over 6. So then we need to divide both by 3. And so now we end up with theta equals pi over 18, and theta equals 5 pi over 18. And so it's kind of like the theta value. Okay, it goes out at pi over 18 and 5 pi over 18. All right, however, we need to write them in polar pairs. All right, and so polar pairs are in r comma theta. So what is r of this intersection? 3. All right, because it's literally going to be the same. Even if you substitute it back in, it will still be 3. And so 3 comma pi over 18 and 3 comma 5 pi over 18.
Write the coordinates of the points of intersection using now rectangular coordinates.
All right, so what do we need to know for rectangular? So x is equal to what? R cosine theta. So what is r? 3. And then cosine of theta. All right. And then we have y is equal to, what's my r? 3. And then sine theta. All right. And so this is where our calculator is going to be needed. Hopefully you're in radian mode. And so now we substitute in. Now we have 3 cosine of pi over 18 and 3 cosine, or sine, sorry, of pi over 18. So what's my x value? .9544. And then my y value is 5209. All right, and so that ordered pair is 2.9544, comma 0.5209. All right, I don't need to write this next part. Hopefully we can do it. How do I get my next ordered pair? I substitute in what? 5 pi over 18. So our r is still going to be what every single time on this one? 3. So now I have 3 cosine of 5 pi over 18, and I have 3 sine of 5 pi over 18. So our x value is?
1.9284.
And our y value is?
2.2981.
Find drd theta at theta equals pi over 4. Interpret the meaning of your answer in the context of the problem.
All right, fantastic. So a lot of the times I like to talk about the interpretation of it. What is drd theta going to do?
How fast the radius is going out or in.
Good.
As it
All
goes
right.
onward.
How fast it's going away or from the pole. Exactly. All right, so what do we need to do? We need to take a derivative. However, what do I have in my hand? A calculator. What am I going to use? I'm going to math aid it. Elena, what'd you get?
Negative 12.7279.
All right, love it. All right, and now let's interpret that meaning. So the way that I always like to say is r is changing at a rate of what? negative 12.7279 at theta equaling pi over 4. Now, if there's a question on whether or not it's going towards or away from the pole, then I'm going to answer what? I'm going towards the pole, all right? Because it's going, it's a negative, so it's going towards the pole. However, unless they specifically ask for that, I wouldn't give it. I'm just going to say, R is changing, okay? But we should know what it does. If it's positive, it's going which way? Out. It's going away from the pole. All right.
For 0 is less than or equal to theta less than pi over 2, there are 2 points on R1 with x coordinates equal to 4. Find the subject points. Express your answer using polar coordinates.
All right. So I need x equaling what? 4. So very similar to what we did for parametrics. So it's in R1, and so R1 is the 6th sine of 3 theta. So let's build what x is. So what is x? It's r cosine theta, right? So what's my r? 6 sine of 3 theta. And then times what? Cosine theta. All right, so that's what x is. And what do I want to do with that? I want to set that equal to 4. All right, so on our calculator, what are we going to do? We're going to graph that. Okay, I personally would subtract 4. All right, and what am I changing my window to?
0 to pi over 1.
No. 0 to pi over 2. So theta is equaling 0.2532. And then theta equals, what's the other one? 0.6962. All right. So now those are my theta values. However, it says express the answers using polar coordinates. All right. And so what do we need to know? We need our r. All right. And our r is not equal to 3. All right. But we need to find our r. So what do we need to do? Substitute it back in. All right, so when we substitute it back in for r equals 6 sine of 3 theta, when we substitute in the 0.2532, we end up getting the r is
4.1318.
318. All right, and then our theta would be the 0.2532. And then our other polar pair, if we substitute in this 0.6962, we'd end up with 2.135. All right, and then we'd have 0.6962.
Write in terms of theta an expression for dy dx, the slope of the tangent line to the graph of R1.
All right, cool. So we built x, so that's good. However, what do we still need to build? Y. And so what is y? 6 sine of 3 theta times sine theta. All right, because what's dy dx? We did this yesterday. Dy dx is really what? Dy d theta over dx d theta. And so, what rule do we need to use? Product rule. So the derivative of my first, the derivative of 6 sine of 3 theta is what? 18 cosine of 3 theta. And then times sine theta. And then what? Plus the derivative of sine theta, which is cosine theta. And then times, all right, 6 sine of 3 theta. All right, and then over the derivative of x now. So now we'd end up with 18 cosine theta times, or of, I'm sorry, 3 theta times cosine theta. And then what? Minus, there we go. So minus sine theta and then times 6 sine of 3 theta. Okay.
Write in terms of x and y an equation for the line tangent to the graph of the curve R1 at the point where theta is equal to pi over 4.
All right, so what do we need for an equation of a tangent line? A point and a slope. So we need to find dy dx at what?
Pi
At theta equals pi over 4. So what do we need to do? Substitute in theta. We need to substitute in pi over 4 into that. All right. Luckily, we have a calculator. Good. You put it in your calculator, you got 1/2. All right. And so then what else do we need? We need a point. All right. And so how do we find our point? We substitute in pi over 4 in for what? X and y. So we substitute them in this for our x and this for our y. And so when you substitute it in, you ended up with 3, 3. Very good. All right. And so now what do we need to do? Put it in the equation of a tangent line. So now we end up with y equals 1/2 times x minus 3 and then plus 3. All right, go for it.
The graph of the polar graph r is equal to 4 minus 4 sine theta is shown to the right. For 0 is greater than or less than or equal to theta, which is less than 2 pi. There are 2 points on r with y coordinate equal to -4. Find the subject points. Express your answers using polar coordinates.
All right, so very similar to what we've just done. All right, so what do we need to find? We need to build what? Our y. And so what does y equal?
4 minus 4 sine.
All right, 4 minus 4 sine theta. And then times what? Sine theta. And what do we want to do with that? We want to set that equal to what? -4. All right. And so what we're going to do in our graph is we're going to, I personally would add 4 to it and then change your window to what? 0 to 2 pi. Theta equals?
3.8078.
And then also?
5.6169.
All right. Love it. All right. However, what do we need it in? We have our theta values, but we need it in what? Polar pairs. All right. And so now we're going to substitute in these theta values in for theta for r. And so when we substitute those in, all right, so we got
6.4720.
comma 3.8078. And then the other one is
6.4723.
723 and 5.6169. All right, and so those are our polar pairs. Okay.
Write an expression for the x-coordinate of each point on the graph of r equals 4 minus 4 sine theta. Express your answer in terms of theta.
All right, what do we need to find? Our x. Well, how do we find x? R cosine theta. So r is what? 4 minus 4 sine theta. And then I multiply it with what? Cosine theta. Do I need to do anything more with it? No, that one's easy. All right. Part C.
On the polar curve, r equals 4 minus 4 sine theta, so that at time t seconds, theta equals t squared. Find the time t in the time interval 1 to 2 for which the x-coordinate of the particle's position is.
All right. I love this. I love this. What do we need to do? We need to replace what? Theta with what? T squared. All right. So now I went from polar mode to what? Parametric mode. All right. And so that's why I think it's beautiful how they tie in. So then I get what? X is equal to 4 minus 4 sine t squared. And then cosine of t squared. And so now what do I want to do with that now?
You missed the 0 sign.
What do we want to do? We want to set that equal to what? -1. All right. And so we would graph that, and I personally would add over 1. All right. And then what would we change our window to? 1 to 2. And so now we find the time equaling 1.5537. All right. All right. Part D.
Find dr/dt at time equals 2. Interpret the meaning of your answer in the context of the problem.
All right, beautiful. We have a calculator in hand, so what are we going to use? Math ate it. All right, math ate. Actually, have we built R yet? No, let's build R first. Let's make sure we all are on the same page. What is R? 4 minus 4 sine t squared. Okay, because this is dr dt. Okay, now math ate it. So then we math ate it and we get 10.4583. All right, let's interpret that meaning. What's happening? R is changing. At t equals 2. All right. What's really happening? Is R getting bigger or smaller? It's getting bigger. It's going further away from the pole. That's really what's happening. However, this is the little cookie answer that I kind of want. All right, part E now.
Find the x dt at t equals 2. Interpret the meaning of your answer in the context of the problem.
All right, we built x already. So here's x up here. And so now what are we going to find? The derivative. All right, so then what are we going to use? Math ate it again. All right, dx dt at time equals 2 is what?
14.4368.
All right, what does this mean?
X is increasing at a rate of 14.
X is changing at a rate.
368 at times equals 2.
Beautiful. All right, which way is x moving?
Right.
It's moving right. So if you ask that question, it's moving right. All right, so x is changing at a rate of that at time equals 2. All right. So they actually did this on their own. We're going to go over it, but we're not going to record that part.